Hello, Niners. This lesson is simply about graphing parabolas. Now, you're given graph the parabola x squared minus 8x plus 12y plus 52 equals 0. Find the coordinates of the vertex, focus, and points of the latus rectum, and the equations of the directrix and the axis of symmetry. First, notice that what we're given is the general form of a parabola. X squared minus 8x plus 12y plus 52 equals 0. And know that this is a parabola since only the variable x is being squared. And if the variable x is being squared, this is either a parabola that opens upward or downward. But before we graph this, we need to convert this first into its standard form. Let's recall the standard forms. So if this standard form, x minus h to be squared equals plus and minus 4a times y minus k, represents all the parabolas that opens either upward when it's positive or downward when the right side is negative. Then the vertex is of course hk. Now when you have a standard form that looks like this, y minus k to be squared equals plus and minus 4a quantity x minus h. Notice that here what is squared is the variable y. You have a parabola that either opens to the right or to the left. So if it's positive, if it has a positive right side, then it's a parabola that opens to the right. Now take note of the relative positions of the special parts of the parabola. Of course, this is your parabola. That point is the focus, the line is the directrix. Remember the definition of the parabola being the locus of a point that moves such that its distance from a fixed point, which is the focus, is equal to its distance from the fixed line, which is this line, the directrix. And if this is negative, if the right side is negative in that standard form, you have a parabola that opens to the left, like that. Of course, the parabola, then this is the focus, that's the directrix. Now let's go back to the problem. X squared minus 8x plus 12y plus 50 is 0. We need to convert this first into the standard form. So x squared minus 8x plus 12y plus 52 equals 0. X squared, what's that again? Minus 8x plus 12y plus 52 equals 0. So the first step is to isolate the variable that is being squared, which in this case is x. So just leave all the variables with x in the left side and just transpose all the other terms in the right side. So minus 12y minus 52. Okay, now, so we can now begin completing the square. The left side we should add here negative 8 divided by 2, that's negative 4, and square, that's the number that we should add. So add 16. So add also 16 to the right side. What you do in the left side, you do in the right side so that the equality stays the same. Now, this is now a perfect square, which is x minus 4 squared equal to negative 12y minus 52 plus 16 will be minus 36. And the last thing to do is to just factor out the coefficient of y in the right side, which in this case is negative 12. So negative 12 times the quantity y, this will be a plus, so plus 3. Be careful in your standard form, because if you get the incorrect standard form, then all your parts will be wrong also. So notice that the variable x being squared, the right side is a negative, therefore this is of this form. X minus h to be squared equal to negative 4a y minus k. So negative means a parabola that opens downward. Relative positions of the special parts. The vertex would be here, the focus should be a point that is below the vertex, the directrix should be the line above the vertex of your parabola. Alright, now let's graph x minus 4 to be squared equal to negative 12 times the quantity y plus 3. X minus 4 squared is equal to negative 12 quantity y minus 3. So that's the standard form. Oh no, it's plus 3. So this should be plus. Okay, now the vertex, start by plotting. Let's adjust first the plane since this is a parabola that opens downward. Let's have this is our x-axis. Okay, the vertex would be the point 4. Remember the vertex hk, so 4, negative 3. Okay, and let's plot the point 4, negative 3. 4, negative 3 would be 1, 2, 3, 4. 1, 2, 3 here. That's the vertex. Now the directrix. The directrix, or dir, is the line above the point. And how many units away from the point, from the vertex? We know this is 4a. 4a is equal to 12. Therefore a is 3. Remember that in the standard form, 4a, the sign will only tell you the orientation of the parabola, whether it will open upward or downward in this case. And you know that a is the distance between the vertex and the directrix. Therefore, the directrix is 3 units away from the vertex, and it is a line 3 units above the point. 1, 2, 3. This line would be the directrix. Let's change the color of that. You can see there. So the blue line also the directrix, and it's a vertical, it's a horizontal line, and the equation is y equals 0, the x-axis itself. Now let's locate the focus. The focus would be a point that is below the vertex and also 3 units away. 1, 2, 3. So here's your focus. Coordinates. Notice that the vertex and the focus have the same x-coordinate. So just copy the x-coordinate of the vertex. And then you move 3 units below negative 3. That will be negative 4, negative 5, negative 6. Or simply subtract like 3. Negative 3 minus 3 is negative 6. Okay, the focus. Now, let us locate the endpoints of the latus rectum. Or let's call it the ELRs. ELR1 and ELR2. Now, the length of the latus rectum is 4a. That's the length of the latus rectum. Latus rectum length. So therefore, in the problem, 4a is 12. Remember that sign, the negative sign, only tells you the orientation. So what the length of the latus rectum is 12, we will divide that length into 2. 6 to the right of the focus and 6 to the left of the focus. So you have 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There are the latus rectum endpoints. Notice again that the endpoints of the latus rectum and the focus have the same y coordinate. So just copy the y coordinate, your focus, M6, M6, and then you know that you move 6 units away from this to the right. So just add 6 to the x coordinate 4. So this will be 10 for this point here, and minus 6 for this point. So you have 4 minus 6. That'll be negative 2. Simply, and you know the coordinates are indeed negative 2, negative 6. So all you need to do again is to connect the parabola using a smooth curve. So just connect smooth curve just like that. There, arrow, arrow, arrow. That's the parabola. Now the axis of symmetry, last thing that we need to get. The axis of symmetry. The axis of symmetry is the line that will pass through the vertex and will divide your parabola into 2 parts. Obviously, this is that line, this vertical line that will pass through the vertex, the focus, and will divide the parabola into 2 halves. And it's a vertical line the equation is obviously x is equal to, passing through the x coordinate, that would be 4. So there you go, all the parts of the parabola. Just remember, be careful in converting your general form into the correct standard form so you can obtain the correct parts. Right now, for practice, I know you missed this part. The best way to learn is to do it yourself. I have here a parabola written in general form. I want you to find this on your own. The answers are here obviously, but this is for your practice. That's all. Practice makes perfect. Good day. Good day, Niners.